Hey everybody, it's Mr. Kingsbury. I thought I'd give you a few pointers about linear equations just to help out. The truth is, as I was thinking about this and trying to put it together, there is a lot here. This is a meaty topic, and we're covering a lot. Now, we've looked at it a whole bunch this year. You also got it in Algebra 1 last year, so none of it should be new. It should be review. But there are a lot of different things that we could talk about. There are a lot of different ways to do different things. So I'm going to try and keep it as simple as I can and focus on kind of the major things that you need to know. So for starters, let's just talk about a line. The equation of a line is going to have some numbers and variables in it, and it comes in three flavors, all right? You've got slope-intercept. You've got point-slope. And you have standard form. And these are named because math people are ridiculously simple, and they like to name things very obviously. Slope-intercept is called slope-intercept because it has both the slope and the y-intercept in it. Okay, so this m, y, and x are just variables. You can substitute any x value and y value from a point into this. The m is the slope, and the b is the y-intercept. Similarly, point slope is named point slope because when you write it, you use the slope and you use any point on the line. So it looks like this. We got y minus y1 equals m times x minus x1. And of course, the m is the slope again. And then the x1 and y1, those are the x and y from a point. So I'll write it like that, all right? X and y from a point, any point on the line. Standard form is the one that kind of gets the furthest away from that. It looks like this: ax plus by equals c. A, b, and c are integers. You don't use fractions. So a, b, and c are integers. And a must be positive. That's really what you've got to know. The trick is to go between them and also to be able to write them. And we'll get into that in just a second. In order to write them, you need to have two things every time: a point and a slope. Now, you can get those things a bunch of different places, a bunch of different ways. If you're given a graph, so here's what you need. You always need a point and a slope to write a linear equation. Always, every time. Now the question is, where do we get those things from? And this is what happens in math, is there's a lot of different places you can get the information you need, a lot of different ways that it can be expressed to you, and you have to be able to take those things and do something with them. For the most part, though, we'll limit it to just three things. Sometimes they can be given to you. That's the first one. When that happens, awesome. If you're given a graph instead, just identify them. Identify 2 points. Well, yeah, identify 2 points. And then from there, you can either calculate the slope or count the slope. Right? Same with the table. You just got to be able to pull that right off of there. Also on the table, side note, the y-intercept has an x value of 0. For example, let's say that I gave you the table that looks like this. Let's go Let's do -2, -1, 0, 1, and 2. And let's say that the values are like this. Okay, this one right here is the y-intercept. Because it has an x value of 0. So what do we do with all of this? Well, we need to know what these different types of equations are, because we're going to go back and forth between them. We're going to try and write them. And I found that those two things kind of end up being the same in a lot of ways. And there are a lot of different ways that you can be presented stuff. And I don't have time in this video because I need to make it fairly short to go over all the different possibilities. I mean, you could be handed any kind of stuff. So I'm trying to streamline it as much as possible here. What you need to remember, though, are what the three different types look like. All right, slope, intercept, point slope, and standard. You need to remember what those look like, and you need to remember that you always need a point and a slope to write any kind of equation, any kind at all. Now, what I'm going to say is the most useful for graphing is slope-intercept, and the most useful for getting to a different type of equation is point slope. So what we're going to do is always start at point slope form, and then we'll go from there to one of the other two. And I'll walk you through that in a moment. The other tool that I need to give you to help out is called the slope formula. Okay, and it looks like this: y2 minus y1 over x2 minus x1 equals m. Okay, all this is you find the difference between the y's and the difference between the x's in any 2 points that you're given, right? So, like, for example, let's say that I give you the points like 1, -2, and 3, 4, right? So each of these is an ordered pair. Every ordered pair has an x value and a y value. And in order to tell the difference between them, we'll say that this is the x and the y from the first pair. So this is pair number 1, and this is pair number 2. So we'll call this x2 and y2. And you can just plug these into the formula, not a big deal. If you don't want to remember the formula, that's fine. All you have to do, remember that you're taking the difference between these. You're subtracting. So, and as long as you start with the same point and end with the same point, you're fine. So you can either set this up as 4 minus -2, started here, ended here, over 3 minus 1, right? Two negatives make a positive, so this becomes 4 plus 2, which is 6. 3 minus 1 is 2, and that reduces to 3 over 1. Or if you wanted, you could go the other way and do -2 minus 4 over 1 minus 3. That's fine too. I started here and I ended here for both of them. You just have to make sure that whatever point you start with that with that same point on the top and the bottom. -4 minus 4 is -6, and 1 minus 3 is -2. And when you simplify this, the negatives cancel, and 6 over 2 reduces to 3 over 1. You get the same deal. So that's how you find the slope pretty quick. If you have a graph, by the way, or if you want to graph these, that's fine too. You can count up and to the right or to the left. That's fine. Or down. And I always like to go up and to the right or down and to the right. That way I know if I'm going up, it's a positive slope, and if it's down, it's a negative slope, and it works out really easy for me. You can also count it. All right, not a big deal. So how do we then, once we found the slope, how do we go from one type of equation to another? I would say always, always, always start with point slope form. Okay, so how do we convert? We need two things before we can do that. Remember what they are? One, we need points. So find your points. You need at least one. If you're given the slope, all you need is one. If you're not given the slope, you need two. Second one would be find the slope. If you're given the slope, this is good. If you're not given the slope, then you use my slope formula up here, or graph it and count it. That's fine too. The third thing then is you plug into the point slope form. You're always going to do that first. Okay, now if the goal is to write something in point slope form, then after you've plugged in, you're done. You don't do anything. You don't distribute, you don't move anything, you don't cancel anything. You literally just put the slope and 1 point into this bad boy and you're done. That's it. Usually though, we won't ask for that because you're usually asked, what is the slope or what is the y-intercept of this line? Those are very important things. The slope tells you the rate of change. So if it's talking about business or something, it's how much you're being paid an hour, or how much you're putting into savings per month, or how many gallons you get to the, or how miles you get to the gallon, or how many miles you're traveling per hour, or how many people you can fit into a room per square foot or something. I mean, it's a rate, and that's why it's important, is it's telling you how much you can change the total number by. The other number, the y-intercept, is important because that tells you where you're starting, right? Like if we were talking about savings, the y-intercept would be how much money's already in your savings account. If we were talking about, how much you've earned working at HEB this year, you might say, hey, you've earned so much money up through April, and you want to figure out how much money you're going to earn through the end of the year, and you know how many hours you work per week and so forth. You could start with the amount of money you've already earned and then figure out how much more you will earn for the rest of the year and add the two together. It's that kind of deal. It's the down payment you make on a car. It's the number of people that are already at a party when you show up versus the slope, which would be the rate that they're showing up to the party or something like that. So they're important, which is why slope-intercept form is very, very, very important, and why usually that's where we head. And in fact, that'll be the second form that we go to. So right here, once you have a point, at least one, and the slope, you can plug into point slope form, and then you can use that to go to either standard form or slope-intercept form. You're actually going to go to slope-intercept form first, and then you can go from slope-intercept to standard. So the next thing you're going to do when you're switching equations is you're going to distribute the slope. Distribute. I can spell distribute. D-I-S-T-R-I-B-U-T-E. Distribute the slope. That's going to happen no matter what. And then the last thing that you'll do is you will cancel the constant on the left. Always, every single time. And what that will do is that will put you at slope-intercept form, right? So this gives you point slope form, point slope form. This will give you slope-intercept form. So if that's what you're looking for, you can stop at 5, okay? Now, if you need standard form, then you need to go on and cancel the x term, the term with an x in it on the right. Now, from there, you have a step you may or may not have to do. If once you're done with step 6, the coefficient of x is positive, you're done. Remember, we said that in standard form, the a value has to be positive. Well, the a value is the coefficient of x, so it has to be positive. Okay, so probably once you've moved the x over, you will want to do two things. You may or may not have to do them. One of them is you'll want to get that thing positive. So you might have to do step 7, which is change all the signs. That's totally legal. It's like multiplying by -1. You just have to make sure you change all the signs of all of the terms. The other thing you may have to do, possibly, is you may have to do step 8, and that is multiply everything by denominators. And what I mean is, if any of your coefficients or the constant are in fractional form, you need to multiply all 3 terms by that denominator. It's not a big deal. What it does is, for the term that has a denominator, it cancels that out. And for the ones that don't have a denominator, it just makes the number bigger. It's not a big deal. And I don't even know that we're going to look at one of those today, but I wanted to mention that. So let me see if I can give you just a couple examples really, really quick so you can get a feel for this, all right? Let's just start with 2 points. Let's say I give you the point 2, 5, and 7, 15, all right? And I want to see all 3 forms. Well, first of all, I need points. I don't have a slope, so I'm going to need 2 points. I've got 2 points. Next thing I need is slope. Okay, so step 1, we found our points. Check. Step 2, I need a slope. So I'm going to do that by subtracting here, right? So we'll make this x1, y1, x2, y2. So we need to find the slope. I'm going to take 15 and subtract 5. That's the top of my fraction. Then I'm going to take 7 and subtract 2. That's the bottom of my fraction. 15 minus 5 is 10. 7 minus 2 is 5. So I'm left with the fraction 10 over 5, which reduces to 2 over 1, or just 2. That's my slope, my m, if you will. So step 1, get the point. Step 2, got the slope. Check. Step 3, plug into point slope form. No problem. So point slope form is y minus y1 equals m times x minus x1. Obviously, my m is 2. We figured that out, so I'll put 2 in here. I'm not going to change this y, and I'll leave the minus, and I'm not going to change this x, and I'll leave that minus. What I am going to do is take one of these 2 points and plug it in here. It doesn't matter which one. You can do either or. It's totally up to you. I have a tendency to like to use the points that have the most positive numbers in them and the smallest numbers. In this case, they're all positive. 2, 5 is smaller. That's just a personal preference. If you want to use 7 and 15, you can. I'm going to use 2, 5. It also helps that 2, 5 is marked as x1 and y1, and that's what I'm substituting in for, so it makes the substitution a little easier. That just happens to be a coincidence. So y1 is 5. So instead of y1, I'm going to put 5. I've replaced that. Step 2, or not step 2, I shouldn't say. I'm sorry, that'll be confusing. What I mean is then I replace x1 with 2. This is point slope form. So if that's what I was asked to find, I'm done. If I was asked to find slope form, though, then I'm going to do steps 4 and 5. Step 4 is we distribute the 2. So all of this on the left side will remain unchanged. On the right side, though, I'm going to do 2 times x, which is 2x, and 2 times negative 2, which is negative 4. And then step 5 is cancel the constant on the left side. So I'm just going to look on the left side here. There are 2 terms, y and negative 5. I'm going to cancel the one that is a constant. That means there's no variable. That would be negative 5. The opposite of subtracting 5, or a negative 5, would be a positive 5. And what I do to one side, I do to the other. So let's look at the sides separately. On the left side, negative 5 plus 5 is 0. And y plus 0 is just y. So that's what's left on the left. On the right side, the 2x is not having anything done to it. So we just bring down 2x. Over here, I've got negative 4, and I'm adding 5 to it. So negative 4 plus 5 becomes 1, right? It's like I owe someone $4. I have 5, so after I've paid them back, I have $1 left. What I have now is y equals 2x plus 1. That is my slope-intercept form. Now, if I need this to be in standard form, I'm going to go ahead and do step 6, which is you take the term that has an x in it on the right side and you cancel that. This is a positive 2x. The opposite of a positive 2x is a negative 2x. And what I do to one side, I do to the other. So let's start with the right side. 2x minus 2x is 0. 0 plus 1 is 1. That's going to be my right side. On the left side, I have y minus 2x. You cannot combine those because they're not like terms. One has a y, one has an x. So all we can do is write them out. Now, technically, you can write it as either y minus 2x, or you can write it as negative 2x plus y. Either way is fine. I'm going to write it as x first and then y, because typically mathematicians like things to be in alphabetical order, and we read left to right in our culture. So I'm going to put it in alphabetical order from left to right. That means I'm going to go negative 2x plus y. And we're almost at standard form. There's one other issue. I need my x coefficient to be positive. It is not. So I'm going to make negative 2y a positive, negative 2x into a positive 2x. I'm going to make plus y into minus y. And then on the right side, I'm going to make positive 1 into negative 1. And that will be my standard form. Okay? Whew. So if I gave you 2 points, or you were given 2 points and asked to put it in standard form, that would be what you would need to do. I'm not going to lie, there are other ways to do this. There are ways that you could probably go a little bit faster, maybe, but I don't know that I want to teach them to you because they get very confusing. This will work every time you go through the progression of all three. If you need to stop there, you can. If you need to stop there, you can. Or if you need to go all the way, you can. I have a couple other examples. Let me just do one really quick, just kind of a different situation. You're going to like this because in this situation, instead of giving you 2 points, I'm going to give you a point and I'm going to give you the slope. So technically, steps 1 and 2 are done. I got a point, I got a slope. So the next move is plug those into point slope form. Negative 3 is my slope. We'll call this x1 and this y1. The y and the minus don't change. The x and the minus don't change. And the equals doesn't change. So what goes in for negative y1? Well, y1 is negative 5. What goes in for m? M is negative 3. And what goes in for x1? That would be positive 3. By the way, both examples I gave you have these numbers being the same. That's coincidence. I didn't mean for that to happen. So be on the lookout. It probably will not look like that. Okay, these are not supposed to be the same every time. Let's see. Next move. Let's put this in standard form. Now let's just put it in slope-intercept and call it a day. So next move, we're going to distribute the negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. On the left side, normally I would just copy it because I'm not adjusting anything. I did notice there are 2 negatives, and 2 negatives make a positive. So I'm just going to make that adjustment as I copy it. So I get y plus 5 equals negative 3x plus 9. And the only other thing I have to do then is cancel this constant. The opposite of positive 5 is negative 5. And what I do to one side, I do to the other. So let's take it in pieces. On the left side, positive 5 minus 5 is 0. Y plus 0 is y. Equals. On the right side, negative 3x has nothing being done to it, so it stays the same. 9 minus 5 is positive 4. So I get my slope-intercept form. Y equals negative 3x plus 4. Fair enough. The only other example I could give you would be a really, really simple one, and that would be if you were given, say, something in slope-intercept form, let's say, like maybe 2/3 x plus 7, and I ask you, hey, put this in standard form. Really, all you have to do is make sure that the x term and y term are on the same side, make sure there's no fractions, and make sure the x coefficient is positive. So the first thing that I would do is cancel the x term. This is positive 2/3 x, so I'm going to subtract 2/3 x. On the right side, 2/3 x minus 2/3 x is 0. 0 plus 7 is 7. On the left side, I can't put those together. They're not like terms. So I will simply write negative 2/3 x plus y. That equals 7. Next thing, I noticed that the coefficient is negative. What do we do there? We change the signs of all three. So negative 2/3 x will become positive 2/3 x. Plus y will become negative y. And 7 will become negative 7. Now, I added one other little piece here that we hadn't looked at before. It's not a big deal. But do you see how this is a fraction? We don't want fractions. Standard form doesn't have fractions. So to get rid of that fraction, we're going to multiply by the denominator of this fraction. In this case, it's 3. And before I do that, let me just remind you that this y does have a coefficient. It looks like it's just minus y. It's technically minus 1y. So what I'm going to do is, this denominator is 3. So I'm going to multiply that term by 3, that term by 3, and that term by 3. And here's what happens. For this first one, the 3's just cancel and leave me with 2x. That was the whole point. On the second one, I've got negative 1 times 3. That's negative 3. So negative 1y becomes negative 3y. And then lastly, negative 7 times 3 is negative 21. So standard form here is 2x minus 3y equals negative 21. I'm hoping that helps you a little bit. I'm hoping it doesn't confuse you at all. Certainly you can email me if you've got questions. I'm glad to try and help out. I would also suggest, if this still isn't enough, you're welcome to search videos on YouTube or go to Khan Academy and look for these things. They have them pieced out in little bits. Hopefully you can find some help somewhere on the interwebs. And if not, again, I'm here for you to email me. I'll be glad to answer those between 8:30 and 5:30 pretty much every day. Hope you're doing all right, and I'll talk to you later. Bye.